Hi, Michael. So thank you very much for joining this call on event delivery challenges at scale. Hopefully part of a bigger series where I'm talking to engineering leaders about the challenges they have and the approaches they take to delivering events at scale from their platforms, API platforms, to their customers. So we'll start with a little bit about you. Who are you? And tell us a little bit about Paddle.
So I've been here at Paddle for about 2.5 years. I'm a senior engineer in the DX team. The DX team has quite a few different disciplines. I'm in the back-end side of things. My background generally has been 10 years, primarily in e-commerce before I shifted over to developer experience at Paddle.
And then, yeah. I mean, tell me a little bit about Paddle. What's the platform? What does it do? What problems does it solve?
Paddle, in a nutshell, it's a merchant of record. So we take care of all payments and the liabilities that come along with that. So your tax, your PCI compliance, honoring refunds, chargebacks, and things like that. What we want from our users is they can just plug Paddle in and then scale globally without having to worry about having to set up local entities in different countries around the world to handle your tax and remit that properly. It's very difficult. But Paddle, yeah, we do that for you.
And then all API driven. Do you expect like the developers that use the platform to completely do things programmatically, or is it a combination like some manual setup within a dashboard?
Yeah, so developers would generally integrate. So you can go through the dashboard route. We have a dashboard, and there's a lot of development tools within there, so you can integrate through that way. We also are completely API first, so pretty much everything that you can do in the dashboard is driven by our API. So we kind of dog food our API ourselves, right? And so everything that we're able to do in the dashboard, you're most likely also able to do via the API. Event delivery for us is quite a big thing, not just externally, but also internally. So a lot of our infrastructure is mostly event driven. So a lot of, so we use microservices internally, and so a lot of our processing, our asynchronous processing and things like that happen through events internally. And then we have one of those services is what we call the notification service that handles the external events that we pass to our users. So our API and our events kind of are tied together quite closely. And that was an intentional thing. And what you see in our events that you receive is generally a one-to-one representation of what you would have got if you hit an endpoint in the API. So it's the resource.
So the payload structure is very similar to the models that you have. And then in terms of the notifications or the event types, are they often, potentially not always, but often kind of CRUD events? Someone's created a new resource, someone's updated one, deleted one.
Yeah, we have a lot of general like life cycle. So verbs like in the past tense are like updated, created, and things like that. The naming is generally like entity.event, and we have also ones that are state-based. So like transaction.pastDue, for instance, is like a more of a state-based one. But yeah, there was a lot of thought that went into the naming of the events, and to try to keep that consistent throughout all of the events as well. But it also comes into like the convenience events. So you see those lifecycle ones that I mentioned, like updated, that could also have a convenience event next to it that is cancelled or build. So we'll fire an updated one because the resource updated, but also because it updated to maybe the status of build, we also fire that convenience event to say that is transaction.build. And what that means is that when you subscribe to our events, you can subscribe just to a subset. So you could ignore certain ones and just have, I don't want every update that happens to a resource. I just want the build one, please. And send that to here. And vice versa.
Yeah, so like topic-based subscription or filtering, or it's positioned slightly differently depending on the platform, but that makes a lot of sense. And it's been looking at the ecosystem specifically with Shopify, one of the value adds that Hookdeck did offer was the ability to filter events, because their events were very noisy. But in more recent iterations, they provided the ability upon subscription to filter out those events, which you've done from the start, which definitely improves the developer experience, and also that reduces the resource usage from both probably your side, but also from the consumer side. Okay, so then in terms of the event delivery to the developer, to the consumer, those are webhooks, right?
Yeah, when one of our users go and subscribe or create a subscription to a to a subset of events or all events. This creates a destination with that platform, which that can be one of two things at the minute. That can be HTTP endpoint, or it can be an email endpoint.
Oh yeah, that's interesting. Yeah, the consumer of the event is ultimate. Yes, it's delivered via email, but consumer is a human being rather than a system. So I can see why that makes sense. Yeah, it's in the event destinations initiative, the talk is very much focused on system delivery, different types of endpoints, webhooks, RabbitMQ, those sorts of queuing systems. But the human side of things actually hasn't been mentioned. But it's interesting that you do have destination types. It's just one of them is email for human consumption, and the other one is HTTP for machine consumption. And do you ever see anybody? Do you know if ultimately those events are kind of delivered and consumed by HTTP, processed in real time, and the logic handled by your customers there, or do quite frequently your customers push these things onto queues and then asynchronously process them? And have you ever had anyone, hey, could you just deliver this to our queue?
We advocate that you take the request, you put it somewhere like a queue, store it. It might be the database. Just put it somewhere where you can process it asynchronously, so that we can get the response back as soon as possible. Obviously, a lot of the nature of webhooks and what you do with them is that they're tied to maybe some other integration, especially for us. So webhooks are kind of core to a lot of user flows that they have. So you might find that a lot of the products that are using Paddle are using it to manage their subscriptions, so their sign-up process, their upgrades, their downgrades, their cancellations. So a lot of these things incur some other processing that may be heavy, right? Especially if it's syncing to another platform, or maybe running some automations and things like that. So we always advocate that you respond as soon as possible. We also have a timeout of 5 seconds, which is relatively low. But we feel like it should be more than enough to be able to get a response back. In the early times, we did have some issues with more timeouts. I think that's reduced down quite a lot significantly as we've moved on. But I don't think we've got specific requests to go directly to something like AWS or RabbitMQ or things like that.
I also think it's an unknown possibility. My assumption is that companies like Stripe and Shopify have had a problem with endpoints of their customers, because there's enterprises, there's much smaller companies that may have spikes, and they've ultimately had to deal with the fact that they're delivering over HTTP and people are timing out, and they've gone, well, if we instead advocate for them exactly what you're doing, advocate pushing to a queue, then you're still pushing that problem to the consumer and saying, okay, you still need HTTP, but you've got to put infrastructure in place to push things on a queue and then asynchronously process it. Whereas I think they've gone, well, probably some of the big customers anyway are using EventBridge on Amazon or GCP PubSub, and they've kind of gone, well, actually, if we push directly to that and encourage people to do that, then it removes the load on us having to deal with timeouts and so on, because we know that those systems will ingest. But it's also great that Paddle recommends Hookdeck as an ingestion platform, because effectively it's a serverless queue. And one of the interesting things there you said around the fact that there's a 5-second timeout, which should be generous enough, certainly if you're doing asynchronous processing. But one of the changes with using something like Hookdeck is that we have a 60-second timeout, which often allows people to continue to ingest an HTTP request, actually perform some of that logic, and then not have to worry about managing retries themselves. They push that onto, okay, if they couldn't process in 60 seconds, or if something failed and they want to return a 500 or some other code, they know that Hookdeck will retry it once they've resolved that problem on the platform. But it's a shift in mindset in terms of like delivering directly to a queue, or going almost against best practices of going, I deal with this asynchronously, to go with Hookdeck, I can process synchronously, and that's one of the values that the Hookdeck brings.
Yeah, and I guess you get that from other event buses as well, right? So if you was to consume an event within EventBridge, SQS, you will get by default, I think, 30 seconds timeout, which you can increase quite heavily if you wanted to.
Yeah, I mean that's exactly what dead letter queues are for, isn't it? Okay, well, this payload has been failed to be processed, we'll push it on there. So you always need something like that. So it has to fall back somewhere to go, this is just consistently we'll retry it, or this is consistently failing, put it somewhere.
A system that's reliable needs to be able to perform within a certain, we have an SLO, service level objective, of 2 seconds latency from the point in which the event is being emitted internally to the point in which it's being attempted. So our service itself within the platform is actually averaging around 40 milliseconds from the point of ingress to the point of attempted first attempt. And in terms of reliability, we also want to make sure that we handle those retries. So it's making sure that if failures do happen, say a timeout happens or the endpoint is completely down, we can't reach them, then that goes back and we retry that process, and that's an exponential back off. We kind of also document all of our exponential back off configuration inside of our docs so that you can easily see the frequency in which would retry. Then we have item potency checks, because we don't get guaranteed. We have no guarantee that our internal events are only delivered once. They may be delivered more than once. So we have to do some item potency checks on our side to make sure that we're not delivering that more than once to the destination. So that's quite important to us as well. And then we have obviously security, which is huge for us. So we've got to make sure that what we send can be verified. So every destination that you create, when you create it, you also get a secret key with that. And we sign every attempt that can be verified on the user's side by taking their secret key, checking it against the timestamp and the body, and then creating a signature on their side and comparing it to the signature that we created from our side. That way they can ensure that there's no one else trying to hit their endpoint and forge any requests or anything like that. So that's quite important. And I know not all platforms do that. So it's very important to us. Obviously, we talked about consistency and the naming and things like that, and how that ties to our actual API, and trying to keep that consistency through the webhooks as well, which is also very important to us. But simplicity is also another thing, right? So we talked about the convenience events and being able to just whittle down our subscriptions down to specific ones that we care about. Obviously, that's quite important. But then we have our SDKs. So our SDKs also allow you to plug in the verification. So these things that might not be super easy for someone who's new to this. And let's face it, like hashing and HMAX and things like that are not always the easiest thing to do. So yeah, we handle that within our SDKs. In some cases, we also provide middleware that you can easily just plug in.
Are they for specific frameworks and runtimes?
Yeah. So like, so Go one, I think specifically has some middleware in there. So you can just integrate your middleware, and then at a point in which it's got to your handler that it's verified and it's secure, and then you can take that payload. So, and then that final point is quite a big one for us, and it's being testable. So what we find a lot of is there's a lot of scenarios and a lot of places where you can't easily test what a stream of webhooks might look like. So something happens in the platform, a customer downgrades or upgrades or cancels and changes things, a billing date or things like that. That's going to incur some stream of events to hit you. And what we have is a webhook simulator that we kind of built from the ground up to allow us to simulate what these events look like, and send those with real data where possible. So you can plug in your actual data to this, and it sends real webhooks over to the destinations that you've created. So they're real destinations. They have the secret signing, and you can test this from end to end, essentially, without actually having to go and do that yourself.
As I said, so that's not just individual events, that's supporting workflows, so multiple in specific sequences.
Yeah, so you can do individual ones, and we've supported that for quite a little while, and we've supported that with real data most recently, past couple months, I think it was, when we launched that for single events, which is very useful for just kind of getting the ground running and without having to go and actually go create a product and then see a product creation. You can just go, okay, I want to receive product creation events. Instead of having to redo that every single time, let me just click send again and click, so you can keep on repeating that and have that come and kind of, integrate at your own pace and debug your issues and figure that out whilst going again and retrying that. And like I say, all integrates with the exact flows, literally the exact flows that we said for webhooks. So it integrates all of the same timeouts, all of the same signature verifications, using the same destinations, etc. So yeah, super important. And having those, which we've recently released, those scenarios possible, is really, really helpful. Yeah.
Michael, would you mind sharing? I mean, I appreciate this can be a tricky one to share, the details you're allowed to share and so on, but what sort of frequency of events do you send? Can you give us any insight to the volume? Maybe more insight into areas of patterns of events that might be interesting within the paddle system?
I think what we find mostly is that event delivery is extremely spiky, which makes it hard to be. I mean, there is a predictability, and we see this during the day. We can definitely see the ebbs and flows of the day, and that's natural, and something I've experienced quite a lot with e-commerce as well, right? So certain points of the day, certain areas of the world wake up, and we start to see an increase of activity. That we definitely see this activity come through on our webhooks. So if our platform's getting busy, we tend to see it graphed within the webhook deliveries before we kind of see it across the entire platform. So it's quite a good early indicator for the load on the platform as well. In terms of like how many attempts we do, it's a tricky one to put a number on. It's always growing, it's always increasing. I think from 2 years ago, I was involved in our Black Friday, Cyber Monday, and testing and getting ready for that and prepared. And then we went through it without a hitch. But I think the numbers that we did that year, so this is not last year, but the year before when I was involved in that, we are doing it like day to day now. So growth wise, we're definitely seeing kind of like a high growth there. And in terms of within those like couple of weeks, which is generally our busier period. I know there have been other weeks as well that we've said, oh, this is actually busier than the Black Friday week. But yeah, we've definitely seen like a 5-6 times increase compared to normal. So it's quite easy to say that, from when I was involved in that one the other year, we've increased by 5 or 6 times general scale.
So I guess that's a combination of more customers for you, right? The business is doing well, but also I think all representative of increasing online commerce, e-commerce, isn't it? Because Shopify, at scale that they're quite, certainly during Black Friday, Cyber Monday, they had that, live view of the volume. But you can see in their figures, the increases year on year. But the fact that you're saying that you're getting Black Friday, Cyber Monday scale from your perspective, like day to day now is a great indication of significant growth.
Yes, definitely a good indicator. And obviously, and those weeks are still here. So the busy period is still that 5-6 times increase still happens. But yeah, now it's just with large numbers. But I think one of the things that's quite interesting is like keeping that kind of reliability as well. So we tend to aim for I think it's 3 nines in terms of delivering, attempting before 2 seconds, right? So the first attempt of an event from the point it was emitted to the point at which we attempt of 2 seconds, that's our kind of service level objective. And I think we're about 3 nines, just over 3 nines on that. So that's quite important to us to keep that as high as possible, especially during those busy periods. But yeah, and we get an increase not just from these period of times, but we also have a lot of sellers that are migrating from other platforms. So we have migrations from our own classic platform over to our newer billing platform, which we're talking about now. Then we also have migrations from Stripe and other providers coming over to Paddle. And what they do is they generally bring a lot of their existing customers' subscriptions over with them, and to kind of keep everything in sync and integrate on their side, quite often they listen to the events again. So we might import 1,000, 2,000, 10,000, 30,000 subscriptions within a short period of time, and we see a large spike in events because all of those funnel through and do all of the general life cycle things of a subscription, and then come straight through as events into the notification service where they find out the subscriptions created. So yeah, we definitely see increases from imports and things like that. Yeah, it's interesting to see that load happen and be able to take from what is day-to-day traffic and what is your general traffic and being at that scale, and then scaling up automatically to handle those imports and those spikes, which can happen at any time, unpredictable, and catching that. So we scale mostly off of our queue size. We do have other scaling mechanisms in place for like the CPU and memory usage of our workers, but generally speaking, they all sit comfortably around the 40% mark. They're probably slightly over provisioned, so they're comfortable. And then the queue sizes increases the amount of workers that we have, so we can scale out and handle that as quickly as we can, really.
Well, that's a really good segue into the next question, which is if you can share a little bit about the components and the architecture you build to allow this event delivery at scale.
Yeah, definitely. I'll start from the left. I'll just call this the event bus for now. Let's pop that up there. Our event bus drives into kind of like an ingress queue.
How do these events get into your event bus? Is that from like third-party systems? Is it from your own systems?
So this is entirely the internal platform.
Right. Okay.
So we can kind of like presume there's multiple of these services. Oh, that's not what I want to do. Let's try that. Multiple services that are kind of running here, and these will all kind of like push into our event bus. There we go, try that again. So these all come into the event bus. So this might be like a customer service, it might be a catalog service, it might be the transaction or subscription service, things like this, right? Like that will be emitting events and coming into our event bus. And there's various different places in the platform where this might happen. Say if we take in a transaction, that fires off quite a lot of events from different services as they're handled. Just a general checkout will create customers, it will create transactions, it will potentially create subscriptions, addresses, businesses, quite a lot of things. So a lot of that traffic will come straight through onto the event bus and into our ingress queue, because we ingress almost every event. Every event that we push out externally, we have to consume internally first, obviously. So that comes into our ingress queue. We then have a set of workers tied directly to our ingress. And these will happen over here. So these are queue workers. Just pop these out of the way for a sec. So our workers will consume the ingress queue, and from this point they don't do much with it at this point. At this point, we just want to use this as almost as a proxy to our service.
Are those workers capable of processing any type of event, or do they also are they only interested in? Are they dedicated to specific types of events?
Yeah. So these workers will consume everything within this queue. So the queue itself has specific subscriptions that it takes from the event bus. That are the ones that we care about. They're the events that have external mappings to them. That can be mapped to webhooks, whereas this worker will just consume everything within this queue and deliver it to our notification service. And these workers here will handle any failures of our service. So if this service has gone down, if there's any timeouts or anything like that for whatever reason, maybe we've got quite a lot of load at the moment and we haven't scaled quick enough. This generally doesn't happen, but if it does, then this will go into the DLQ and be retried. Well, it'll be retried, so it'll go back into the queue, it'll be retried, and everything at this point is idempotent checked. with the notification service. So when it comes into the notification service, we check the idempotency of that to make sure that we haven't processed it. We are currently processing it, and if we are, we fail back to the worker so it knows that we either already processed it or we're currently processing it and we can't take it again, kind of thing. If there's an entire failure at this point and the worker can't retry, it's exhausted all of its retries, which is kind of similar to our general, it's quite similar to our webhook dispatching as well. Like, it will exponentially back off to a certain degree. I think it's a much shorter exponential back off than what we have for our external users, but it will then eventually DLQ. But yeah, so that comes into there. At this point, this our service is responsible for checking that event, making sure that it's good to consume, making sure it's the right shape and it's valid, making sure that we are not currently processing it. It's not like it's not been delivered to us twice, for instance, but then by multiple workers, or we haven't just processed it before, because it might be that it's somebody's replayed, some other service has replayed an event for whatever reason on their side. Maybe they had an outage on another service and they had to replay events. And if we have obviously consumed that event already, we want to return that. We've already consumed it, and we don't need to handle that again. So that gives us kind of safety net almost. But within the notification service, we generally have a Postgres DB, and then we have a Redis cache as well that we keep. Let's just call it cache for now. So this is our persistent store. So this allows us to generally create events, and but we don't actually do anything at this point here, so I'll remove that. But we do have a cache. We do utilize a cache when it first comes in on Ingress, and what we want to do at this point is to create a lock. So we want to create a lock because this service itself is auto-scaled horizontally, so there might be multiple of these running at any given time. Well, there is always multiple running, but there may be even more. And obviously, with this many workers running, the chance of potentially having more than one of an event delivered to us is quite possible. So we lock on an event. We create the idempotency key. We lock on the idempotency key to make sure that if it's currently being processed by one of these services, then we're not going to process that. So that gives us that. And there is, to be fair, it does interact with the database as well, because we check to see if we haven't already consumed that idempotency key. So that gives us that. And then at this point, it goes down to back into one of multiple queues. So this is a prioritization job when it initially comes into here. And then we have like a default, a high, and a low queue. So depending on the job we take in, the event we take in depends on where this goes.
And is that based on the event type, or is it based on who it's for, like a priority from a customer's perspective? These are high priority customers, or how is that prioritization determined?
Yeah, so it generally depends on the event itself. So things like imports. So if we get any events from imports, they would generally fall into a low queue because they're a lower priority than the live traffic. If we have retries from failures, which happens in one of the workers, they will push into the low queue because
it's already delayed.
It's already been delayed at this point, and also you're kind of trying to prevent that kind of noisy neighbor impact there at that point, because if you got one that is clearly down because we're failing to deliver to them, if they have a high volume of them failures, we don't want to push them back into like one of the higher default queues, because then that's going to potentially delay other live traffic where their destinations aren't down. So we want to push those into a queue where it's less impactful. Most of our default queue processing is like metadata processing and storing data into the database for that, and email deliveries. We also, as a service, consume emails So, but we won't dive into that one. That's completely separate. So, but attached to all of these queues is a set of workers. Obviously, we have multiple of them. I'm just trying to indicate that there's multiple, but
yep.
Each one of these queues have that tied to them, and are consumed independently. So at this point, so our default is generally used to metadata and things like that. So it interacts with our data store more than I think. Go that way, and rarely much else at this point. Our high queue is responsible for our immediate deliveries. So these ones will then, if we copy that, I'm just going to call this the user destination. So that's where we want it to go. Generally, these workers are going to be sending straight out there and attempting that delivery. In between here, there are a few other things that are hard to map out. Generally, like things that sit in between our service and the external network, and some security things to check. But generally, this worker, as far as the service is concerned, is going directly to the user, attempting that delivery with a 5-second timeout, and then we'll come back here. If it times out, if it fails, obviously we have error handling within the worker, and these will go back and interact with the data store as well to update state and things like that. Fairly simple implementation there. There is also the fact that this worker, if it gets a timeout, is going to requeue into the low.
Oh, interesting. Right. Okay.
Oops.
Yeah, it doesn't bubble all the way back to the notification service. It has the responsibility of putting it onto the low queue.
Yeah, exactly. So we're dispatched directly onto the low queue, and then at that point, obviously we've updated the state. We've set it to failure for whatever reason. We've set the exponential back off to whenever we need to next retry it, and we put. In fact, that's technically wrong. Actually, let me remove that. Sorry, we do update the database, and we have a separate process that runs and pushes it in here.
Oh, okay. Just see if you've got like a listener on the
let me map it from
data change on Postgres.
Yeah. So it's probably easier to visualize as like the notification service. It's like a sub process that runs, but we'll query from here for the ones it needs to retry next, because we back off exponentially. It's not always an immediate retry. Obviously it's an immediate retry almost, I think it's within 60 seconds. We try the next one, and then obviously exponentially backing off. But this might be hours before the next retry if it's failed so many times. So yeah, this goes into the database, status updated. The next we set up the next retry at, and then we have a process that picks that up and requeues into the low queue with a delay. So it picks it up within, I think SQS has a 15 minutes window, so you can't delay any more than 15 minutes. So we queue within the 15 minutes, so we can delay it so it's more accurate to when we're going to actually try, and then the workers pick that up, and they too will try to do deliveries.
Yeah, it's quite interesting. So this is Postgres on AWS. I don't know what they've called that. Is it just Postgres? Redis, SQS for queues. Is that the AWS? There's an event bus as well, isn't there?
Yeah, so the event bus is up. Yeah, so that's just the event bridge.
Right. Okay. So you are right. Okay. So you're using an event bridge, which I know within it has the event and bus component. Right. Okay. So a couple of times you said simple, and I guess that's interesting because this doesn't look simple, but this is a simplified version of what you've got. So one of the points of this conversation and conversations like it is to raise awareness of a problem space that I don't think many people know exists. But when you have it, you know it's not. You know it is a reasonable challenge, right? This is a reasonable challenge to build and maintain and scale this. Like as you were going through this, you mentioned with the notification service that it scales horizontally.
Yeah.
I get with all of them, you can throw more resource at them, but at some point you probably need to consider horizontal scaling, unless you're using a serverless infrastructure, in which case that's obviously that sort of thing is managed for you. But in cases where you have to manage the scaling and there's a ceiling on the vertical scaling side of it, you then need to think about horizontal scaling. So
yeah, I think what you could boil this all back down and say, we take data into a service, and then we could directly go and try and send it. But what you'd miss there is a lot of the intricacies around the failure points and the noisy neighbor problems, and what happens when you're ingesting so much, and you need to be able to scale out at that point to be able to consume them at the rate that you need to. While I said it was simple, I feel like we try not to overcomplicate the implementation. So we try to keep it as simple as we can to make it, the DX team look after this one, and most of the kind of like what you'd expect to be developer focused services. It's not the only service we look after. But yeah, for us, it's making sure that it's maintainable. And it's not overly complex until we need to get there. If it gets to a point where the scaling that we have is not enough, then there might be something else that we need to look at. And that's where it gets interesting.
And then also there's a layer on top of this to provide observability to developers on the platform. You talked about deadlet queues and things like that, find out what things failed, what succeeded. You talked about state management story stuff in Postgres. So I'm guessing there's a layer kind of around that to allow a dashboard to be built and various other things. So there's additional complexity on top of that as well.
Definitely. A lot of the data we capture data for every attempt, which is both the request and the response, and persist them. And we make them available within the dashboard. It also goes without saying that this service itself gets user traffic. So it has its own API, because everything that we expose here, everything that we do through these workers is also exposed through API, because we're API first.
You mentioned you've kind of almost simplified that to a certain extent by being API driven. So as you said, you build your dashboard on top of this API layer. So it's not like you've got things coming in and querying the database completely separately. Whether it's customers writing code to interact with your API or your dashboard, at least you've created a central point for that, somewhere to manage and scale there as well. Okay, great. Well, that's super insightful and demonstrates the challenge. One of the challenges you've got of building and maintaining that. So can you highlight, say, one or two areas where there are significant challenges other than maintaining and building that architecture?
Yeah. Okay. So interestingly, I think one of the early point in this project, one of the interesting problems we had was probably quite more at this layer. So before this, where the other services, because we are event driven throughout the entire platform, these services are emitting their events into the notification and us picking it up, and potentially not and doing the idempotency checks. So we had a lot of we had a lot of difficulty around making sure that we were ingesting the right events, and making sure that we checked them properly, that we, that concurrency issue that we talked about, where there could be something in flight already. So we saw that quite early, and we had to catch those and put resolutions in for that, but also making sure that the services were using the right amount of granularity for their idempotency keys, because we found that some events were different but had the same idempotency keys, and that's because the events themselves didn't have the right amount of components within those idempotency keys to be able to be unique enough. So we saw all these kind of issues quite early on before it became like public service and public traffic. So that was quite good to catch those things, obviously, before it went out and ensure that they're solved. And I think what we get day to day now, more than anything, is probably this area, and ensuring that we're handling these failures properly. It feels like every now and then we still get a new error that props up that we didn't expect. They're few and far between now, but definitely went through a period of like, where did this error come from? We didn't
so that's beyond timeouts then. It's not as simple as...
So different responses from different destinations. Obviously, we have no control over what they send back to us. It's just, and checking that. But various errors around like maybe DNS and things like that, or the things that I mentioned sit in between here and here, where we have some internal things that it goes through before it gets to the external side of the network. We had to pick up on things there and make sure that those are resolved.
What challenges do you think your users, the developer consuming your events, have? What are the biggest challenges they have, which may feed back into errors that you're then having to deal with?
Yeah. So I think early days, the most obvious one was the timeouts. It's making sure that we're advocating for those, the right way to process those events. But what was quite obvious up until we released the SDKs and kind of baked that support in there and made it took a lot of that pain away, was around the verification. And I think this is probably somewhere where as an industry it's not as standard practice everywhere. While signature verification isn't too complex, but if you're kind of just getting started and you're not really familiar with this kind of webhook processing, then signature verification might also be new. And we definitely got a few cases where the users were struggling to verify their payloads, and sometimes it would work periodically, and it turns out that they would mutate maybe their request when it was incoming, something that they'd have something relatively small within their stack that would just ever so slightly mutate the payload. Took like UTF-8 character processing or something like that, something that you wouldn't maybe expect or visually see because you don't see the difference, but the actual difference it makes to the signature verification was quite large. It would obviously
this makes a lot of sense. You talked about the middleware now, because you can kind of say use the middleware option and push it to the first thing that processes that inbound request, because then you avoid those mutations.
Yeah, exactly. And we've had a few cases where it would be before it reaches the actual service that the user's written their processing code, that they'd have some layers in front of that, which would be doing something ever so slightly to the request before it reaches their service, but that was enough that they'd mutated it enough that the raw payload wasn't there anymore.
Or something. Okay.
Or even just that it took too long to go through those proxies, those layers before it reached their service, and now the timestamp we recommend, a 5-second variance, I think it is, has lapsed. So then they have to think about what's delaying their processing before it gets to that point. Why is it already essentially timed out at that point? And if there's something they need to tweak there, but yeah, that's probably the most amount of pain that the users get in terms of that, and we've hopefully taken a lot of that away from them with the SDKs and those middlewares and those functions, so they can just throw a payload, or in some cases like with PHP you can pass it a PSR7 object, and then they can get we verify that for them entirely. So yeah, there's different ways in which it's done in different SDKs, but it's fundamentally the same. It's just taking that pain away.
I mean, at Hookdeck we've introduced this idea. Previously we had sources, and sources had verification types, and within there's towards 50 different verification types, and yes, some of them are aliases, some of them are just to make it easier people, and we've now called it source types to kind of make this where the data's coming from the key thing. It's coming from Paddle, for example. But yeah, the number of providers that implement this differently is, there are things like standard webhooks, and there's been other attempts to standardize this. I think the biggest problem is it's out there already, and a lot of services aren't going to change how they do it. And I don't know what the solution is to that, other than education. And as a platform, if you're saying you're ingesting our webhooks, here's the best practice for it, so please follow these. Because even if people don't initially follow it, the support team or whoever handles customers, if it's a customer success person or sales engineer, if it's a deeper integration, can go, just make sure you're following these best practices. So
definitely, I think we advocate for a lot of different things, a lot of things in our docs, and we try to detail it as much as we can to make it as clear as we can, right? And we took on a lot of user feedback in the early days on our docs, and we continue to take that feedback. So whenever someone has an issue or runs into an issue, it's like we look to see where maybe where they got confused, or if they got confused with a certain step within the docs or something like that, or if something was fundamentally wrong. Are they using an SDK? What did they run into there? Was it because they was using an SDK with a specific framework and that was causing an issue? So certain node frameworks, for instance, like I mentioned before, that would potentially change the raw body. So the way you'd access the body, usually you wouldn't get the raw body, you'd get a mutated body of some kind. So it was us looking into those kind of things, taking that feedback, looking into it, trying to solve those problems, and then pushing those solutions back out to the users, either through the docs or in the SDKs directly. So it's helpful.
Yeah, okay. And so webhook verification, you've obviously provided best practices around timeouts. Timeout limits seems reasonable in 5 seconds. They're also having to deal with spikes in activity. Is that a common problem you might see, that hopefully when they do an import, when customers do an import, they'll expect that sort of thing, or they won't have the subscription set up yet anyway, so they won't be processing them. But there, as you say, like Black Friday, Cyber Monday, a lot of people plan ahead and provision additional resources, but still, if they're more successful than they plan. So those are ongoing challenges that I think any event delivery platform is going to have.
Yeah, so that's definitely something that we've seen. I think our users obviously understand that we will retry. So if they have some level of outage, that they will get a retry, and they can replay notifications, or in fact just read them either from the API directly, or consume the events API to kind of backfill anything that they may have missed if they had some downtime. But yeah, that kind of like, it's definitely possible that users would kind of have that back pressure, I guess. And we try to, we're looking at different ways we can solve that. I don't think it's got to a point where we see it with a lot of our customers. It's maybe just been a handful every now and then. So, and it's normally during those really busy periods, or if they've just not scaled up for a sale that they launched recently or something like that. So, but yeah, it's kind of taking that feedback and trying to figure out the best ways that we can solve it for them, instead of them having to solve it. So we can solve it for more than one person. That's a good thing, right?
You talked about webhook verification being a problem, and this is a conversation around event delivery challenges, and thank you so much for the insight on that. Obviously, the Event Destinations Initiative exists, and companies like Stripe and Shopify do now support these other destination types, not email, interestingly, but they do support these. One of the things I was wondering around that is there a value as well in terms of those having very standard and enforced authentication mechanisms, whereas webhooks, you can't enforce that a subscriber, a destination verifies that webhook. They can still ingest it and go fine. Obviously, that's entirely on them. But if you're delivering to a destination that enforces authentication, one, the authentication mechanism is standardized. Two, it's enforced. So I think there's another potential. In addition to the idea with event destinations is that you're choosing destinations that maybe more naturally scale than HTTP. You're removing the need for the complexity of putting an HTTP layer in front of the queue that eventually you're going to put it on, or the queuing system. But then there's that additional, and people get to use their existing tools. I know there's a lot of HTTP tooling, but if you have a lot of tooling around RabbitMQ, or you've invested in CloudFront and your own tooling around dead letter queues and things on AWS, you can use all that already and not have to deal with the HTTP layer. But that authentication one isn't something I'd really thought about before. But what do you think?
I think it gives us peace of mind more than anything, right? So obviously there's benefits to the end user where they get to use all of the tools they're maybe familiar with, and it kind of integrates directly into their infrastructure, and they can handle kind of that subscription flow if they wanted to on the side of like their queues from their event bus, and handle all the dead letter queues and give them ultimately control, right? But I think from a verification perspective, it gives us that peace of mind from the sender that it is being verified and it is going somewhere that there's less risk of one of our users being targeted by or attacked by webhooks, and obviously that's definitely a concern. It's why we have those signatures in place. It's why we have the verification process. But like you say, you can't guarantee that everybody's using that and actually enforcing it. So yeah, it gives us peace of mind, I think, more than anything, which is definitely important still.
Thanks, Michael. Thanks ever so much for your time. Really insightful to share that internal knowledge around how you've built out your, I guess, effectively event ingestion through to event delivery architecture at Paddle. I'm hopeful that anyone that watches this will have a big learning from that. So if they're building themselves, or whether they decide to choose to try and find a different solution, something that they can, I guess, buy versus build. But if anyone chooses to build, I think you've provided a reasonable blueprint for people to look at, and some of the considerations in terms of specific details in terms of item potency and managing multiple workers, but also through to the delivery side of things as well. So thank you ever so much for your time, and I'm pleased we had this chance to have a conversation about it.
Yeah, thank you. I'm definitely looking forward to the series. I'm going to hopefully learn something myself. So.
Cool. Thank you.